So array values, you random, basically create array of given size and fill it with random numbers. On the data, loop through array sequentially. Method to output the values in an array. Iterate through the array. So search tests, create an object of the linear of the scanner class and search key location of the search key in array, create array and output it. Get input from the user. Okay. Just about 1 minute. So this is the main function to test the linear search tests. So if position is equal to -1, integer was not found. So print the integer was not found, else integer was found. And then get input from the user. So we have, like, say here 16, this is the elements of the array. Please enter integer values 48 we are trying to search was found in position 4. Because the starting index is 0, so 0 is 16, 35, 68, 10, 48. So 48 is position 4. Then we enter 60, 60 was found in position 7. 33 was not found, and -1 is to quit. Okay, any questions here? So this is showing the same we did in C++ in Java. Big O notation indicates the worst case runtime for an algorithm. In other words, how hard an algorithm has to work to solve a problem. Constant runtime. Order of 1 does not grow as the size of the array increases. Linear runtime. Order of n grows proportional to the size of the array. Constant runtime, order of 1 does not grow as the size of the array increases. Linear runtime, order of n grows proportional to the size of the array. Quadratic runtime, order of n square grows proportional to the square of the size of the array. Linear search time algorithm. Worst case algorithm checks every element before being able to determine if the search key is not present. Grows proportional to the size of the array. Sometimes the simplest algorithm performs poorly. Their virtue is that they are easy to program, test, and debug. Sometimes more complex algorithms are required to realize maximum performance. Binary search, more efficient than linear search, requires elements to be sorted. Test the middle element in an array. If it is the search key, algorithm returns. Otherwise, if the search key is smaller, eliminates larger half of the array. If the search key is larger, eliminates smaller half of the array. Each iteration eliminates half of the remaining elements. Class that contains an array of random integers and a method that uses binary search to find an integer. So make sure you mute your mic, all of you. So binary search divides into half each time. Create array of given values and fill with random integers. The range 10 to 9. Sort the array. Binary search low, high, data length -1. So middle is low plus high plus 1. Location is equal to -1, return minus if not found. Do loop to search for element. Print remaining elements of the array, output spaces for alignment. The element is found at the middle. Middle element is too high, so eliminate higher half, otherwise else eliminate lower half. So middle is low plus high plus 1 divided by 2. While low is greater than high and location is equal to -1. Return the location if you once you found it. Method to output string values in the array. So remaining element like low and high you take and then output spaces for alignment, output element left in the array, and method to output values in an array here, remaining elements, and this is the binary search test. So create an object of the scanner class, and then this is the search key, the position, location of search a key in the array. Create array and output it. Get input from user. Please enter an integer value minus one to quit input.next and read an integer from the user. Repeatedly input an integer minus one terminates the program. While search integer is not equal to minus one, use the binary search to try to find integer. Return value of minus one indicates integer was not found. Else, print the integer the integer was found. Get input from user. So please enter an integer value 23. So you search for it. And this is greater than like the half the value. So 42 is the middle. And then again 24. So 23 is found in position number 1. The first position is position 13, which is position number 0, and then you have 23. Please enter an integer value minus 1 to quit. So 75 here. So we are searching for different values here. So 75 is found. So then like eliminate the first half, and then we again look at the second half because greater than the middle number, and so on. Binary search each compression solves half the size of the remaining array. Results in order of log n, called logarithmic runtime. Sorting data, placing data into some particular order. A blank sorts checks by account number. Telephone company sorts accounts by name. End result is always the same, a sorted array. Choice of algorithm affects how you achieve the result, and most importantly, how fast you achieve the result. Okay, so let's see here. Placing data into some particular order, bank sorts checks by account number, telephone companies sorts the account by names. End result is always the same, a sorted array. Choice of algorithms affects how you achieve the result, and most importantly, how fast you achieve the result. Okay, so placing data into some particular order, a bank sorts checks by account number, telephone companies sort accounts by name. End result is always the same, a sorted array. Choice of algorithm affects how you achieve the result, and most importantly, how fast you achieve the result. Can you hear me, all of you? Selection sort, simple but inefficient sorting algorithm. First iteration selects smallest element in the array and swaps it to the first element. Each iteration must select the smallest remaining unsorted element and swaps it to the next element that's front of the array. After ith iteration, the smallest ith elements will be sorted in the first elements of the array. It's shown here variable to store index of smallest element. Loop length minus 1 times. Loop over remaining elements. Locate the smallest remaining element and swap smallest element with the first unsorted element. So this is the main function. So pass the values for the first pass, second pass, and so on. Okay, so this is the sorted array shown finally. Outer loop for loop iterates over n minus 1 elements. Inner for loop iterates over remaining elements in the array. Results in order of n square. Insertion sort, another simple but inefficient sorting algorithm. First pass takes second element and inserts it into the correct order with the first element. Each iteration takes the next element in the array and inserts it into the sorted elements at the beginning of the array. After I iterations, the first I elements, okay, after I iteration, the first I elements of the array are in sorted order. So let's see here. So we put Java to region to random here at the top, and we have insertion sort. Okay, so let's see here. Fill array with random integers in the range 10 to 99. Sort the array and loop over data dot length minus 1 elements. So iterate over length minus 1 elements, store value to insert, search for location to place inserted element, move one element to the right, decrement locations to insert element. So this is the array sorted and search for sort method to output values in an array here. Okay, 4 important steps for developing. Let's see here. So this was insertion sort. To hold the variables. And this is the sorted array finally. Efficiency of insertion sort. Insertion sort, outer for loop iterates over n minus 1 elements, inner for while loop iterates over preceding element of the array, results in order of n square. Then you have the merge sort, more efficient sorting algorithm, but also more complex. Splits array into two approximately equal size subarrays. Sorts each subarray, then merges the subarrays. The following implementation is recursive. Base case is one element array which cannot be unsorted. Recursion step splits an array into two pieces, sorts each piece, then merges the sorted pieces. So it calls recursive helper method. Test for base case. Compute middle element, middle of array. Compute middle element one pot to the right of middle. Then we have reducted recursively sorts first half of array. Recursively sorts second half of array, and then we have merged the data into correctly. Okay, so let's see here. Let's see the merge sort. Merge sort more efficient sorting algorithm, but also more complex. Splits array into two approximately equal size subarrays, sorts each subarray, then merges the subarray. The following implementation recursive. Base case is one element array which cannot be unsorted. Recursion steps splits an array into two pieces, sorts each piece, then merges the sorted piece. So here is the merge sort algorithm. Create array of given size and fills with random integers. Calls recursive method split. Recursive split method to begin merge sort. Splits array, sorts subarrays, and merges subarrays into sorted array. Test base case of size array equals 1. So split array in half, split each half recursively. Merge two sorted arrays after split calls return. Okay, so here private void merge basically. Output two subarrays before merging. Merge arrays until reaching end of either. Okay, place smaller of two current elements into result and move to next space in array. So if left array is empty, fill with empty of with the elements of the right array. If right is empty, fill with elements of the left array. Copy back values back to the original array. Okay, any questions here, anyone? So method to output certain values in an array is shown here. Spaces for alignment, return empty. Method to output values in an array. So this is a merge sort test. Let's see who else we have. Print down sorted array, and then call the sort function to sort it and print the sorted array. So you can have this unsorted array split, okay, into halves, split further, then you have 75, 56, 85. So then sort it, so then you have 56. So 56 and 75, 56 comes before 75, so 56 comes before. Then you have 56, 75, 85, and then you have to split the other half, 90, 49, 49, and 90 you have. And then you add it, so you get 49, 56, 75, 85, and 90. Then you split 26, 12, 48, 40, 47. So you have 26, 12, 48, and 14, 47 on the other half. So then you have 26 and 12 and 48. So you have 26 and 12. So 12 comes first, so 12, 26, and 48. Then you add 14, 47 to it. So it becomes 12, 26, 40, 47, and 48. Merge. So 49, 56, 75, 85, 90. And this is the sorted array finally. Merge sort far more efficient than selection sort or insertion sort. Last merge requires n-1 comparisons to merge entire array. Each lower level has twice as many calls to method merge, with each call operating on an array half the size, which results in order of n total comparisons. There will be order of log n levels, results in order of n log n. So here you have linear search, binary search, and so on, selection sort, insertion sort, merge sorts, bubble sort, number of comparisons for common big O notations is shown. If an assertion is an assertion that is true before and after a portion of your code executes, most common type is a loop invariant. Invariant. Loop invariant remains true before the execution of the loop and after every iteration of the loop body when the loop terminates. Four steps for developing a loop is from a developing loop from a loop invariant. Set initial values for any loop control variables, determine the condition that causes the loop to terminate, modify the control variable so the loop progresses toward termination. Check that the invariant remains true at the end of each iteration. So this is about this the merge sort, binary sort, and so on. Okay, any questions here, anyone? Now let's see here. Let's go to the exercise. Can you see exercise 15? All of you? Do you hear me, class, or no?
Yes, Professor.
Yes, Professor.
Okay, so can you see exercise 15 or no?
Yes, Professor, we can see.
Okay, try exercise 15. So this is based on this algorithm concept. Let me know once you're done. So then we'll go through it and then we'll start the presentation today. Okay. So best of luck to all of you. Let me try it and let me know once you're done.
Ayman, 88 mo?
All of you work on exercise 15. Let me know once you're done with it. Yes, Avinash, what happened? Tell me. Avinash, you raised your hand. What happened? Tell me.
Oh, I thought I am not able to hear your voice.
Okay, no, I assigned exercise 15 to be work on. I did the notes. and then after that, I ask assigned exercise. Please let me know once you're done.
Yeah, Professor. Thank you. Okay. Fine, Professor.
बोल। हेलो। हाँ बोल। क्या ढूंढ? नहीं भाई, ढूंढ रहा हूँ। वो साले मैं क्यों बताऊँ? अभी नहीं, जब तक नहीं होएगा तब तक मैं किसी को नहीं बताऊंगा वैसे इसके लिए। हाँ, 4-5 लोग के पास तो गया हूँ। वो बताते हैं, मुझे बोला। बाकी कुछ नहीं, तेरा तो सही है, तेरा बच गया है। तो साले मैं तू बच ही गया है ना, मैं वही तो बोल रहा हूँ। कब? भाई वो उसने वो भाई नहीं रहा था तो भी वो अपनी माँ थी। मैं करता क्या इसमें? तो छोड़ बे। अब है ना, अब कुछ सोचना। नहीं भाई, अभी वही साइड में देख रहा हूँ। कहाँ? मु- भाई अभी सब प्लान्स है ना हेवे है। कोई देयर इज नथिंग फिक्स्ड राइट नाउ। हाँ बट राइट नाउ इट्स completely हेवे। आई एम नॉट श्योर व्हाट आई एम प्लानिंग। कहाँ? आज नहीं आया था। नहीं, न्यूयॉर्क नहीं आया था आज। तो इतना थका हुआ क्यों लग रहा है? इतना थका हुआ क्यों लग रहा है मेरे को? अबे भोसड़ी के असाइनमेंट दिया है उसने, और आज प्रोजेक्ट के बारे में वो बता रहा है कुछ। हाँ, लेक्चर ज्वाइन कर। अभी असाइनमेंट चल रहा है और प्रेजेंटेशन भी लेने वाला है आज वो। क्या नहीं, वैसे तो टाइम है उसमें, बट पता, हाँ वो तो 8 तारीख का ही है। हाँ। मोस्टली नहीं, अभी नहीं। पता नहीं। हाँ। हाँ।
Are you done with the exercise? So we can go through it with you. Class, are you done with the exercise or?
Yes, Professor, we are doing.
You're done? Okay, good. So let's go through it with you. Can you hear me or no?
Yeah, we can hear you, Professor.
Yes, Professor, we can hear you.
Okay, first question. Which of the following is a way to sort data? What is the answer for question 1? Anybody question 1?
D.
D. All of the above, correct. 2. How many comparisons will the linear search algorithm make if the search key is not in array is not in an array of 10 elements?
10.
It will be 210, correct. Which of the following is not a name for the big O runtime?
B.
B. Variable runtime. What is the efficiency of linear search?
C.
B. O of n.
C. Order of n, yeah. What is the maximum number of comparisons? Number 4. We did how many questions? We did 1, 2, 3, 4, and then we have the 5. What is the maximum number of comparisons required to find a search key in a 31 element array?
5.
5, correct. To the power of 5. Yeah. Which of the following is a negative of binary search? What is the answer for question 6?
C.
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 The data
Data
matrix.
union sorted orders.
Professor.
It is 6 is C. Is it clear? Okay, now then we come to we did 6, 7. What is the term used for binary search runtime?
Constant random.
Logarithmic
Logarithmic runtime.
runtime.
Yeah, question 7 is D, logarithmic runtime. 7. 7 we did, no? 8. What does the first pass of selection sort do? Tell me, number 8.
D.
D, locate the smallest element in the array and swaps it into the 0th position. Number 9. What is the efficiency of selection sort?
B.
9 answer is A, order of n square. Selection sort. Selection sort, the efficiency is order of n square. Number 10. What does each iteration of the insertion sort algorithm do? What's the answer for 10?
B. A.
B.
B. Each iteration takes the next element in the unsorted portion of the array and inserts it into the sorted portion. 10. 11. How much faster is insertion sort 15 with a 15 element array than with 60 element array?
D.
D. Yeah, correct. 60 by 15 is 4, so 4 square is n square, isn't it? Just 4 square is 16. Okay. So which number was it?
So what is the
11, no?
answer, Professor?
C.
For which-
D. 16.
16.
Which question were we doing?
11.
11.
11 is D. 11 is D. Okay. What is the base structure? It's 12. What is the base case for recursive merge sort algorithm?
C.
C, a one element array. 13. What is the efficiency of merge sort?
C.
It is C.
C.
So
Yes.
this was 13, isn't it? 14. Which of the following is which of the following sorting algorithms is the fastest?
C.
It is C, a merge sort, correct.
Oh, Professor, can you tell the 10th one?
Okay. 10th one is what does each iteration of insertion sort algorithm do? That's the one. So that answer is B. Each iteration takes the next element in the unsorted position of the array, inserts it into the sorted portion. Okay, any other questions here? So that's done. So let's go. Question 2 you want to know. Question 2 is B10. Question B2 is B10. One is D, yeah, and 2 is B. One is D and 2 is B. Okay, any other questions, anybody? One is D and 2 is, so one is D and 2 is B. Okay, any other questions, anybody? Okay. So no other questions. Okay, now let's open the project and discuss the project. So the project is posted. So let me make it available to you. So project is made available to you. It's going to be due in 2 weeks. So you have to create a presentation and I'll read what you have to do. So do a research on the internet and write about a topic. So choose a topic from the topics done in class, get it approved by the instructor. So like linked list is there, then, what do you call arrays, those type of things, trees.
Professor, you're not sharing the screen.
Write about the topic, explaining it with examples. Minimum 200 words. Create a PowerPoint.
Professor, we can't see your screen.
No, it's not on the screen. It's on the project is posted on the, what do you call? I can share the screen too, so you can see it too.
In Canvas, yes, sir. It's there.
Professor, it says we should get it approved. What do you mean by get it approved?
So you have to let me know.
Okay.
Email me, okay?
Okay, so why don't you pick a topic from the topics we covered in class? Okay, all right, got it.
So did you get the project, all of you? Okay. So
Is
write
this
a
like
code
an
example.
individual project or are we teaming up?
No, it's an individual project. So this has been going, I've been given this project for every semester, so usually people do it individually. So and then you present the PowerPoint presentation in the class too, and write a code example like, minimum. So you can have like more than one code too. It's not necessarily like one program, you can have like 2 or 3 programs and write 100 words. Any questions on the topic? Anything anybody is not clear? On the project. Okay, I'm going to call the attendance. After that, we'll do the presentation. We have to do a lot of presentation, I believe. So we have some time today. I've given to complete some presentations. Let me take the attendance class. Did the student survey came out yet, or did you start doing the student survey yet or no?
Professor.
Yeah, did you start doing the student survey yet? Did the student survey become available now or no?
No,
No, they usually send us an email when they do, but we didn't get any.
Mhm. Okay, so we have, let's see. Benjamin is here or no?
Yes, Professor, I'm here.
Janam is not here today, or is he here?
Janam went to campus today, so
I'm here,
he can
Professor.
explain. Okay, all right, he's here.
I'm here.
Okay.
Janam,
Because Benjamin is
Hello.
here.
yes, Professor.
Okay, I'm calling all the names. Okay, then we have Chaitanya Ala. Chaitanya Babu Ala.
I'm here, Professor.
Okay, then we have Neil Kant Amrutya.
Yes, Professor.
Okay, then we have Syed Reddy.
Yes, Professor, I'm here.
Okay, then we have Nathaniel Baez.
Here.
Okay, then we